Hey guys, today I want to show you a couple of different ways of making surfaces in Rhino. And I know that we have talked about planar surfaces and solids in Rhino, but as you can probably imagine, there is a lot of different types of objects and surfaces that we can make. And once we've made those, there are a lot of different ways in which we can affect those. And so given the fact that we are moving towards a exercise that has more potential for complex objects and also for objects that revolve around a center pivot or that have some amount of curvature, I thought it'd be a good time to show you different ways of making surfaces. And if you have a surface, different ways that you could potentially change them. Okay, so the first, we're going to go through a series of commands, and hopefully that doesn't take too long. And then we'll go through a series of secondary commands that are about how to make changes to or affect different things about the kinds of surfaces that we are going to build. Okay, so the first thing that we're going to look at, first thing I'm going to change, I'm going to go to perspective. And you can see here that I've already drawn a bunch of curves and sort of done all the setup. And then above you'll see the names of each of the commands. And these commands will do to some of these objects once we have made them. So the first command that I want to look at is loft. If you remember, actually before loft, when we had a curve or an object, we had talked about extrusions, right? And the reason for extrusions was because an extrusion created still a planar surface, right? So we could extrude and then select the direction and produce, right, a kind of object, okay? Right, so we covered that one, but now let's talk about lofting. So lofting is a command that creates a surface in between two curves. And so you can actually just type loft. It's very easy. And you select curve A and curve B and press enter. And you see here, it makes a surface. So I'm going to press OK. You can see this surface has a lot of curvature. It's kind of crazy. So I'm going to actually delete it. And I'm going to do it again. I'm going to type loft. And I'm going to this time be careful and select somewhere close to this endpoint of this curve and somewhere close to this endpoint of that curve. Press enter. And you'll see that surface, right, is has a lot less curvature, and it's a lot more, in a sense, direct, right? It's like the points here are being like lofting to the points towards here. Okay, so and I'm going to do that one more time. And if we do this again and we do it in reverse, right, opposite, we'll see that we get that sort of extreme thing. So if you do actually happen to get this, that you can actually align the curves. You can hold on to this button and then change the alignment or not. But that will work. So let's try that one more time. And I can actually change that. Yeah. So if I hit that, it's not the line, but if I hit the button, I can see the two different options that will come out. Okay. So that's lofting, right? Lofting can happen between straight curves, and in that case, it creates a hyperbolic paraboloid. But it can also happen in curved splines, right? So I can do the same thing, loft here and here, and you'll see we get this sort of wavy continuous surface. And then we can also loft in between closed polylines. So same thing here, this one to this one, right? And so we can you can see now the full gamut of lofting, okay? So there is loft. So now let's talk about sweep. Sweep command, you can do two different things with it. And the sweep is essentially, it is sweeping or moving one polyline across the length of another one. So the first thing that you have to do is you have to take the one that you have to move across and put it wherever you want, right? So in this case, I'm going to move my line to this endpoint here, and I'm going to rotate it so that it's vertical or perpendicular in relationship to the other line. So I'm going to go ahead and type rotate 3D, and I'm going to, in this case, select my axis and then rotate 90 degrees, and I can just do that by clicking here ortho, right? So now I've set up my two curves, and I can now type sweep, and you'll see it asks me what my rail is. So what, the rail or the thing that I want it to follow, and it's this one. And then it automatically asks me what my cross-section curve is, which is this one. And when I press space or enter, you'll see that it essentially sweeps that curve across and creates this sort of surface that has that continuous curve as it flows along the other, right? So we can do that and have it be open-ended and be an open-ended surface, or we can do the same thing with two closed poly lines, in which case you'll sort of create a three-dimensional object, right? So here I have my rail, and here I have this sort of profile of a kind of extruded tube, we could say, right? And so same thing, I type sweep. I select first my rail and then my cross section, press enter. It's going to ask me for a direction, press enter one more time, and there you go, right? And so you can see that it has maintained that profile and sort of wrapped it around that whole object, and it sort of figures out all of the corners for us, right? So it's actually a very handy tool to quickly build a three-dimensional, in a sense, tubular object, right? So there's that one. So now we can talk about sweep 2, right? So if sweep 1 was just taking one rail and one curve, sweep 2 actually now has two rails and one curve. And what it does is it will do the same process, but it will actually deform that curve that is sort of interpolating between the two rails, right? So I have rail A and rail B here, and in this case, I actually made them symmetrical. But if I type sweep 2, it will ask me what's my first rail, what's my second rail, and then my cross section. Press enter, and okay. And so you can see actually, right, like this here, which was my original cross section curve, is not the same everywhere, right? So if I were to move this somewhere else, obviously we can see that that is not the same thing as it matches. So it is, in a sense, transforming across the length of my rails, and it is being interpolated with equal weight on both sides, right? So, but that is another really good way in which to create a complex surface that precisely hits two rails that you have defined for it. Okay, so there's another way in which you can create surfaces. Now let's talk about revolves. So a revolve is basically like a top, if you can imagine, and essentially it just, if you kind of imagine a spindle and you revolve that around a center point, you will create a sort of curved surface, right? So with the revolves, the important thing to note is that you have to have your curve be, again, perpendicular to your circle. So the first thing that I have to do is rotate this three-dimensionally off of this point, my center axis, and I'm going to rotate it again 90 degrees, right? So that it is perpendicular or vertical to that point. And now I can type the command revolve. Select the curve that I want to revolve, And then I'm going to select the start of my axis and the end of my axis. You will notice here actually that the end of my axis has to be, like if I, in this case, I had to define it as vertically exactly that point if I wanted to revolve. And then the beginning, and then I can stop it anywhere, but I'm going to choose to create this complete object. So it's going to be 360 degrees. And press enter. And then now we have a continuous revolved surface. So this would be the exact same as if you were to sort of carve something on a spinning wheel, right? So we have that as that's our revolve. That's a different, that's what single surface, again, complex surface with multiple points of curvature, but that's created out of a single command, okay? And then now we're going to get into some kind of weird things over here, but I still think it's useful to show you. But Rhino can also make surfaces out of edge curves, and we'll talk a little bit about why why that's important and how we can extract some information out of them in just a second. But basically, the edge curve command is you decide what your perimeter is, and then you type edge surface, and you select your 4 edge surfaces, or 3 or 5, however many you have, and it will interpolate and create one continuous surfaces that hits all those lines exactly. Okay, so the thing to note here is that the surface itself can do all sorts of weird things. It can pinch in on itself. It's sort of a very complex thing because it's really trying to do everything possible to hit the curves that define the edges. Okay, and you have, in a sense, very little control of what's happening on the interior, right? So the opposite of that is the network surface. And in the network surface, you define kind of a network of curves. And with the network of curves, then you use that in order to define a kind of topography of surface, right? So in this case, if I type network surface, you'll see here it asks me to select the curves in my network. And usually the best thing to do is to select all of the curves that are going in one direction, and then all the curves that are going in the other direction. That just helps Rhino understand the direction of the UV curves. And we'll talk about that in just a second. And you can see here, it'll give you all sorts of different options. I'm going to leave it as it is, but you can play around. If you change some of these things, it will actually change sort of the topology of that surface. But I can click OK here. And now you can see it's going to actually build a surface that is defined not to the full extent, but by the boundaries of the curves, and is kind of an approximation that approximates the kind of topography that would be created by all the addition of all of these surfaces together. So as you can see, it's not hitting any of them exactly, but it sort of is doing the mean of the surfaces. Right? And then finally, there's another command called patch. And patch is a kind of in between edge curves and the network, in which it tries to keep a certain level of fidelity to the exterior, to the bounding curve, and then tries to use any additional information from any other curves that you give it to sort of create a three-dimensional continuous surface, right? So if I type patch, I'm going to select this curve and this curve, press enter. Select the number of spans. You can leave that there. Click OK. And you can see here that it builds a surface that almost perfectly aligns. If you really were to zoom in, you'd notice that there's some misalignments there. But essentially, it's a good approximation of what that surface would look like, while also hitting this other edge, this other line work that is defining the vertical elements, right? So those are the most important. There are a couple others, but we'll sort of leave it at that. But this gives you a good overview of a whole bunch of different ways in which we can start to create more complex surfaces in Rhino. And once we have more complex things, then the important thing becomes how to understand them or how to extract information from them. Okay? And so that's what I want to talk a little bit about next. And so that's what these commands are down here. And all of this will become apparent how it's useful in this next exercise. It is not mandatory that you guys do any of this, but I do think it's useful for you to understand and see and potentially have as a tool in your back pocket as you guys to begin to work on exercise 6. Okay, but so let's go ahead and continue and talk about contouring. So we now have all of these different types of surfaces. One of the ways in which we can begin to understand them is by essentially understanding, like, kind of in a sense, let's say with this surface, dividing it into a bunch of equally spaced sections and then understanding the what that section, each one of those individual sections looks like two-dimensionally, right? So how we could do that is the first thing we would want to do is define a plane that is perpendicular to this object that we want to essentially cut it along. So I'm actually going to draw a line that is vertical. In this case, I'm just going to select it here and I'm going to draw it going straight up. So now I know I'm essentially going to cut this thing in like if I were cutting a loaf of bread into sections that go vertically up. Okay. So I'm going to type contour and I'm going to select that object. Now I select this point and this point that is vertical and perpendicular to it, right? And now I say how often I want. So I have to select the distance. So I'm going to select 0.25 and you can see now, right? It has sort of given me the intersection of planes every quarter of an inch as they go vertically up across this object, right? So I could hide this. And now I have a series of two-dimensional line works, right? That approximate the topology of this surface before. Now, obviously, we would have to get an infinite number of those if we wanted to really truly recreate this overall, but we could decide that we want to keep this would keep a certain fidelity to it. And for example, if we selected all of them and we extruded those negative 0.25 inches down, right? We would essentially now could imagine how we could sort of recreate this complex object, this complex surface, but now out of a series of flat pieces, right? And understand it as a kind of series of sections that come together to build this object. Okay, so that's contouring. Of course, you can also contour you can contour in any direction. So I'm going to go ahead now and copy the same surface and contour it along sort of this axis, our y-axis. So here in this case, I'm going to do the same thing. I'm going to type contour. I'm going to select that point, but now instead of going vertical, I'm going to go along the y-axis, same distance, and you can see now how we've now sectioned it in a different fashion, and it produces actually, right? It would produce a pretty different object, right? So if I go grab this, and now I extrude those 0.25, right? This object and that object are pretty wildly different, right? Now, of course, I could go back and decide to alter that. Before I do that, I could actually decide to, even before this, I'd said to cap this object, so close it off from the top and the bottom before, and then now do the contour. And I would get closed polylines, which would maybe work a little bit more similar to this, at least, in producing a completely enclosed object. So now I could select all these, extrude, 0.25, and there we go, right? So, but you can still see they are very different, even though they're based off of the same surface, right? So that's contouring. You could literally contour any one of these surfaces. And the important thing to remember is that whenever you're contouring, you're always going to have even spacing, and you have to tell it exactly what that spacing is going to be, okay? So, of course, one of the last thing to mention about contouring is you don't have to add additional surfaces. You don't have to make it look like this, right? You can just contour an object. So I can just do this. I can type again, type contour, or I'm going to cap this again, type contour, this direction, right? And now I can just take each one of these and use them as templates and print each one of these out, right? If I wanted to do that and I had it in this orientation, the best thing to do would actually be to grab all of them, rotate them three-dimensionally so that they are perpendicular to our world plane, right? So that when we look at them in top view, we can see them perfectly flat as templates. And now we could actually move them out of the way of each other. And each one of these would be a template that we could print out and reproduce. Okay. So that's where contouring can be really easy in order to build templates and build these objects in real life. Okay. So that's contouring. Now let's talk about extracting specific isocurves. So in order to do that, we have to explain to you what an isocurve is. And that's very simply, you guys have, for the most part, whenever you guys build something, you'll see that a lot of the times it shows these sort of lines, right? Every time we see these sort of intersected cross lines that happened on your objects, right? So all of them had it. I usually turn them off, but you can see that is the information. And if you look at that information, it is always lines that are going perpendicular to each other. And those are called the isocurves. And they delineate the direction of the surface, right? So one line direction across one direction, I guess. It's a confusing way to really think about it, but is the U is assigned a U, and the other one is assigned a V. Those are just arbitrary. We could think of them as X and Y. But so we can actually extract those isocurves out of any surface in any given location, right? So I'm actually going to take, let's say, let's take this one, and I'm going to copy this network surface, bring it over here. And you can see this network surface. Now, if I type extract isocurve, it's going to ask me to select that surface. I click enter. And then rather than, in contouring where it was just choosing an interval and finding all the curves within that were exactly at that interval, when you extract, you actually select anywhere along one of the specific isocurves, right? So literally I can choose anywhere and it will extract the line that is made up of that isocurve. You can see that it goes in one direction, in the U direction, right? Which has been assigned this order in this surface. Or if I change the direction now to V, it will go in the other direction, right? So we can extract any line, essentially any spline out of the surface and have it exactly mapped. We can actually click D again and do both, and then it'll extract based off of a point that we're interested in finding that is anywhere on that surface, right? So that gives us that. We could do this as many times as we wanted. And then we would have a set of information in order to, much like here, begin to recreate this surface based off of now a series of lines that we have defined ourselves. Okay, so in a sense, the extract isocurves allows you to sort of reverse engineer the network surface, but based off of the curves that you want to use. Okay, so that's another important thing to note. Now, intersect is very simple, but good to know. Let's say you have this surface that is this sort of weird bubbly thing, right? And you want to intersect it with a plane. You want to maybe potentially later cut it in half, but you want to know exactly where that intersection is happening, right? So let's say I'm going to draw, in this case, I'm going to draw a plane. And I'm going to move that plane so that it hits my surface, move it vertically so that it hits it. And in this case, I'm actually also going to rotate it 3D to some random angle just so we can see what happens, right? Right, so if you type in the command intersect, you can actually type it first and then select both objects and then press enter. You'll see that it draws a line at the point where those two surfaces hit each other. And it will draw a line when two surfaces hit each other, and it'll create a point if a surface and a line intersect, right? So that's important to note. So now I could actually delete this and I would still have that registration of exactly where it is that that plane hit that surface, right? So I'm gonna not delete it, but I'm just gonna actually copy this over. So that would be if you just wanted to know where the intersection was. Now I can actually use this to trim each other. So I could type the command trim. I could select these two as my cutting objects. And then now I could use one to cut the other, right? And so it freaked out a little bit right there, but it's fine, right? So you can see I was able to now trim both that plane and the sort of weird top again in based off of each other. Okay. And then finally, rebuilding. So if you guys, I showed you, right? If you guys look at this and we have our surface isocurves on, or we look at this one, you'll see that each of these different surfaces has a completely different number of essentially of points that are influencing how it's built. I'm going to select all of them and I'm going to turn on, and you can see some of them have a very tight grid pattern. Some of them have a very loose one. Some of them have almost no information, right? Those isocurves are very minimal. Same thing here, right? This one will also have a somewhat minimal number of isocurves, right? Okay, so we can actually rebuild the surface and tell it the number of isocurves or points that we wanted to have, and it will actually physically change the surface a little bit. So I'm going to take this surface in this case, which has an uneven distribution of isocurves because it was built from just the edge. And if I type rebuild, it will ask me, see, how many points I want in the U direction, how many in the V, and the degree. Okay, so this is actually very important because this is where you are defining how this thing gets rebuilt. So if I want it to be really tight and I want to have a really tight grid, I could add a lot of new U and V points. And you can see now how this gets rebuilt with a lot more information. So I could click OK. And now this surface and this surface, even though they look very similar, they're actually built completely differently. And so I can affect them very, very differently. Okay, so I'm actually just going to copy this one over. And I'm going to show you what happens even if I change the other parameter. So I type rebuild. And instead of changing the number of points, I change the degree of the curves. If I change them to higher than 3, I won't really notice much. But if I change them to lower, click OK, you'll see now, actually, that same surface is made up of only flat faceted objects, right? So now this is actually a surface that could be built with planar object, because each one of those is a plane. Whereas this one they're all splines and they're all one continuous topography, okay? I could, of course, change that to 2, and it would do something somewhere in between, okay? So there's rebuild, and then I guess once you have these, you can also turn the points on, and directly now that you not only rebuilt it, but you can now start changing it by moving points individually. And you can see how by moving points individually, you completely change and distort the original surface that you have, okay? And that's it. So those are all the different ways of building surfaces. As I mentioned, you probably won't need to use this if you don't want to, but I think it's important to have in your toolkit, especially this idea of contouring and extracting information, because it might be one of the ways that you create your object for exercise 6. So I'll go ahead and stop there, and we'll talk about the next part in the next tutorial.